All right, one last video to help you on this assignment, and that is looking at patterns for Y-linked inheritance. Now we know that there's not a lot of genetic information stored on the Y chromosome, and that the Y chromosome is currently undergoing an evolutionary phenomena where it is in the male species getting shorter and shorter over long periods of time. So we're losing genetic information actually, or losing DNA basically on that Y chromosome over long periods of time in the human population. So not a lot of things will actually follow this inheritance. But hairy ears, which is kind of crazy. So people who have like incredibly hairy ears, this is a male Y-linked inheritance pattern. And so a few things for you guys to know about this, because we never got a chance to talk about this in class. Number one, the trait expression and transmission is only in males. So you're not going to have a female whose father had hairy ears. The female will not have the trait because she is going to inherit the X chromosome, not the Y chromosome, and these particular alleles are carried only on the Y chromosome. There are several other examples, but most of them have not been, proven 100% to be caused by just inheritance on the Y allele. So we'll stick with hairy ears in our examples here. If a male has the trait, so if, for example, a son has the trait, then that must mean his dad had the trait, and because his dad had the trait, his grandfather must have had the trait, and the great-grandfather and great-great-grandfather. So this is at some point, until they find out where that mutation occurred, you could go back generations and generations and generations of males and actually look at that trait in the family, which is kind of cool. And when writing genotypes, don't forget the gene is located on the Y chromosome. So I'm going to just give you an example here. Again, on this, I like to start off with what must be the case, and that is that this is inherited on the Y chromosome. So the males that are shaded here are the ones that actually have the trait. So in filling this out, I'm going to write down X and then Y, and I'm going to just asterisk the Y. This just means that he has the allele for this particular trait of hairy ears. So I'm going to go ahead and copy that and paste it in on all of the guys that have that. Notice on there that it's only the guys that are showing up with the trait, right? This is not something that can be passed along to the daughters. Now, the next thing I like to do is fill out the females on this. So the females would just be carrying their two X chromosomes with other information on it. It's not something that we have to worry about, but we're just putting down XX for all of those. I'm gonna do this quickly. Okay, and then the guys that do not have this are going to just be X with the normal Y. They're not carrying a copy of the allele for hairy ears, and so they can't pass on hairy ears to their offspring. So again, something to notice about this. This father here had hairy ears. All of his sons ended up with hairy ears, none of his daughters, because again, he's just passing along X chromosomes to his daughters. And then in individual 8, he had the hairy ear allele, and so his son had hairy ears, will have hairy ears, along with all other sons he might have in the future. Individual 7 did not have the trait, and so there was no way for him to pass it along. His sons, individuals 12 and 13, are both normal. And then finally, individual 4 will pass along that hairy ear allele to his sons 10 and 11. What I love about the Y-linked inheritance pedigree, it is so easy to know that that is a Y-linked trait because only males will be affected. And if a dad has it, he will pass it along to his sons, and his sons will pass it along to his grandsons, etc., etc., etc. So I think of all of the inheritance patterns, the Y-linked sex trait allele is the easiest of all of them to figure out.